So, my camera's being weird. So today you're going to need a pencil, a pen if you want it, close your pen, a highlighter or a second highlighter if you want to. That is up to you. So here is my beautiful papers. I'm going to scoot it away to reveal my actual paper. So we are going to start with being able to recognize linear and non-linear functions. Okay, this is going to be super fun. Maybe. My papers. Okay. So, boop. So we have a linear function has a constant rate of change. A nonlinear function does not have a constant rate of change. Okay, I'm just going to go in and I'm going to highlight the word linear in green because I want to, as well as up here. I'm going to highlight it a little better. Only a little though, can't be a lot. Boop, see? And then I'm going to go in and I'm going to highlight my non-linear. Non means cannot. Does not have a continuous function. Oh, I forgot to highlight the top word. Did it. Kind of. So, but before we look at some graphs, tables, and equations, we need to remind ourselves of some key information. Just think about it. Okay, think about how we have x to the power of 1. That's just going to equal 1. Anything to the power of 1 equals 1. And that anything to the power of 0 equals 1. It's kind of weird. Just accept it. So, in y equals form, where we have y equals mx plus b, is x risen to a power of 1 or 0? That's a good question. Does x appear in the numerator? Does it appear in the numerator? We will find out later. Okay? We will start with some beautiful graphs. Okay? I'm going to wiggle my paper up just so I can see the beautiful little reminders, even though we don't have to memorize anything at this very second. Okay, so there is 1, 2, 3, 4, 5, 6 different functions, okay? Easy peasy lemon squeezy, okay? We have talked about linear functions so much. Okay, as we can see, the first one, it is a linear function. Awesome. As we can see, the second one is not a linear function. Not consistent. As we can see, this one over here, that is a linear function. As we can see, it does have a 0 slope, but he is still a linear function. As you can see, he's not linear. He's curvy. And the last one is not linear. As you can see, I'm just going to beautifully color my linear and non-linear things. Just the function part, just so my paper could be nice and pretty. Okay? Wow. Insane. Next part, we are going to be looking at some tables. Okay, so these tables, this is going to be a little bit more challenging, just a little bit. Okay. Sorry. So our first one, we have to tell what is the rate of change, okay? The rate of change. So our first one, how do we get from 2 to 4? We added 2. How did I get to 4 to 6? I added 2. How did I get from 6 to 8? I added 2. So it's consistent. It's 2 every single time. But let's look on the y side. Okay, how did I get from 50 to 35? I added 15. How did I get from... Oops, sorry, I subtracted. My bad. Don't add the big numbers, guys. Just because it looks like adding, it's not always going to be adding. As you can see, and I wrote all this in pen, so I can't erase. So as you can see, it is consistently decreasing over here, and it's increasing over here. So that means we have a linear function. Next one. How do we get from 1 to 4? We added 3. How do we get to 4 to 7? We added 3. How do we get to 7 to 10? We added 15. I lied, we added 3. How do we get from 1 to 16? We added 15. How do we get from 16 to 49? We added 33. How do we get from 39 to 100? We added 51. As you can see, this is not consistent. This is not linear. It's not linear, guys. I wrote it, so it must be true. Next part. How did I get from 0 to 5? I added 5. Sometimes we're able to visually see what is happening. As you can see, we added 5 multiple times. And on the other side, we correctly subtracted 4. We didn't add 4, we subtracted 4. So since it's consistent on both sides, this is a linear function. Next part. How did I get from 0 to 2? I added 2. How did I get from 2 to 4? I added 2. And then from 4 to 6, I added 2. Don't forget, I have to check both sides to a story. So 0 to 2, that is going to be plus 2. 2 to 8, that is going to be plus 6. 8 to 18, that's going to be plus 10. Sadly, this was not consistent, so it is not linear. It's not a linear function, as you can see. I'm just going to cutely highlight my little jumps. Boop. Just to remind myself that if it is pink, it is not, and if it is green, it is linear. Sweet. My last part. Boop. This one's pretty easy because we know that y equals x plus 4. That's a linear function. I hope I don't have to explain this too much, but we've talked about linear functions a lot. If you don't recognize it, probably not a linear function. It's just an FYI. Y equals 6 over x. That is not a linear function. He looks weird. Y equals 1/2 x. That is a linear function. It does not have a y-intercept. Interesting. Y equals x to the power 3 plus 1. That's weird. It is not linear. He's not there. And then we have y equals 4. That looks pretty familiar. That is a linear function. Awesome. Okay, these are all of your notes. I'm going to try to zoom out to show you all the beautiful stuff hopefully you have written down. Yay! End of notes.